Hi everybody, this is Mr. Folly, and welcome to, where are we? This is video 5, I suppose. We're going to talk about labs of Big Idea 3. So this is going to deal quite a little bit with the gas law labs from last time, and let's see if we can get them figured out. Collecting gas over water lab. So this is a stoichiometry lab. So there's a reaction that happens in a test tube. So I put metal and hydrochloric acid, for example. And what happens is if I have metal with hydrochloric acid, so if I have, it's typically zinc plus HCl, what I get is ZnCl2, and that's going to be aqueous plus H2. Now H2 is a gas. That gas is then going to go shooting up this tube, not really shooting up this tube, and bubbling down here, okay? So I start with a graduated cylinder full of water up to the tippity top. It's all water, all water. So you fill it up with water, you invert it, make it upside down, and put it in a beaker. Okay. The gas is going to bubble up, and if it bubbles up, it pushes the water out. Okay. So we're going to find the moles of gas that form using PV equals nRT. Hey, there's our moles. Okay. So when you do this, this is where we talk about equalizing the water level. So this eudiometer, which is basically a big graduated cylinder or test tube, has to be moved up or down until those levels are the same. You equalize these water levels so that the pressure inside equals the pressure outside, and we get the pressure outside using a barometer. I just misspelled barometer, but we know it is barometer. All right. We wait until the temperature is the same as the room. Okay, so that means, again, Tn equals T out. And sometimes you'll hear this called equilibrium. So we're going to be in thermal equilibrium and pressure equilibrium. And we'll get into equilibrium more later. But from the same equation, how do I get the pressure? Barometer outside. How do I get the volume? It's the change right here. Number of moles is going to be calculated. R is 0.0821, and temperature is the same as outside. Okay. So errors in this lab. If we didn't equalize the water levels, oh no. And what if we forgot to subtract the vapor pressure of water? So this pressure right here, this is a really common mistake. This pressure is pressure of atmosphere, P out, right, is what we called it, minus the pressure of H2O, because a little bit of water will evaporate all the time. All right. And there's the stoichiometry part for it. So we will do some gas stoich where sometimes we have to use PV equals nRT to get moles of gas. We use moles over moles to convert to other moles. If we're doing stoichiometry stuff, we're starting with A and going to B. And moles equals molarity times volume, right? So molarity is concentration, right? PV equals nRT, but we need to be able to find mole in these three ways. All right. So vapor pressure. All gases evaporate some. Weaker intermolecular forces evaporate more. This is review. We did this just a couple days ago. Vapor pressure is the force of evaporated gas back down on the liquid. So see right here, we've got an evap, and then we have some condense, and then we have some equal. I guess these are actually three different ones, but so I guess we got up and down going all these other places. I guess I have the wrong glasses on for this. So this would be a low vapor pressure. This would be a high vapor pressure. But notice it reaches equilibrium, okay? And this would be strong forces, weak forces. All right. So collecting gas over water needs to subtract the vapor pressure of water, and that will be given to you. All right. So last thing for a calculation is a mole fraction, all right? The weirdest part about a mole fraction is it's a decimal. So what it is, a fraction of one substance to the entire mixture in moles. So if I have a sample of, let's see if I can get my highlight going, a sample of 3 moles of N2, 0.85 O2, and 0.05 moles of CO2, what is the mole fraction? So what I'm going to do, the mole fraction of O2 is just, what's my O2? 0.85 over all the other ones. 3 plus 0.85 plus 0.05. And then I get my answer. A mole fraction is proportional, is the same as the pressure fraction. Okay, so when we did this, the answer was 0.217. So if I want to do the pressure, the fraction, the pressure that comes from that, it's the same thing. Okay. Partial pressure is, what's that X? Remember, this is mole fraction. Okay. So mole fraction of gas times the pressure total. So coming back to some other gassy things, speed of molecules at the same temperature. Temperature is average KE. That means there's a range. KE equals 1/2 mv squared. Notice that's the squared part. More massive would be slower. Less massive is faster. Gas stoichiometry. So that means if I'm going from reactant yields products. So if I have 3 reactants yields, let's say 5 products. Convert into moles. PV equals nRT. Okay. Or maybe moles equals MV. Or moles equals mass over molar mass. And then do the stoich, and then you might have to do it again. All right. Pressure flows from high to low. Tungsten is a metal that is used in light bulb filaments. Is produced industrially by the following reaction of tungsten oxide with hydrogen. Wo3, I already love this equation, plus 3H2 yields Wo plus 2H2O. How many liters of hydrogen at 35 and 0.98 are needed to react completely with 875 grams of tungsten oxide? Okay, so what I'm going to do is I'm going to convert 875 grams of Wo3 into H2. Okay, so I'm going to convert that into moles of H2 times dividing bar. Grams of Wo3, and I didn't give myself my molar mass, into 1 mole of Wo3. So tungsten is 183.84 from the periodic table. 183.84 plus 3 oxygens are 48 is 231.84 times dividing bar. Now I want to go into moles of H2. 3 moles of H2 and 1 mole of Wo3. So 875 divided by 231.84 times 3 is 11.322. So then I want to figure out how many liters of hydrogen that is. Okay. So PV equals nRT. My pressure is 0.98. Solving for volume. Moles are 11.3. R is a constant, 0.08206. And my temperature has to be in kelvins. 273 plus 35 is 308. And my volume will be that answer. 11.3 times 0.08206 times 308 divided by 0.98. And I get, I'm thinking for a second, how many liters of hydrogen are needed? Oh, okay, good. Volume equals 291. That's a lot. But that's the end. So I will say toodles.